Hello everyone, welcome back to Maths Help channel. So we'll be carrying on from last video's topic of circle theorem into an actual worksheet um, for this video. I'll be linking this worksheet in the description, so please feel free to do the questions along with me. Otherwise, just follow along. So let's get started with question number 1. So read through. Point A, B, C are all circumference on the of the circle. So ABC is on circle or represents the center. Calculate the angle H, giving a reason for your answer. Straight away, you should look visually into this diagram they have provided you. It looks very similar to the angle of the center is twice the angle of the circumference. With a glance, you should try and identify the rule you have to use out of the 8. So in this case, um, you know the angle of the center, which is 98, is twice the angle of the circumference. So h is simply 98 divided by 2, um, which is 49 degrees. Very straightforward. So I'm not done with the question yet. They asked me to give a reason. So you can simply type it in or write down angle at center is twice angle at circumference. So if you find these questions quite tricky, try to have the 8 rules next to you so you can follow along with it and have a quick look if you get confused with any of them. So let's move along to question number 2. Point A, B, and C are line circumference of a circle. BC passes through the center of the circle, so O is the center. Calculate the angle H, giving your reasoning for each step. Straight away, it looks similar to angle in a semicircle is 90 degree, which means this angle is 90 degree. So you have to state that angle CAB is 90 degree, and you have to give your reason for each step, which is angle at angle in semicircle is 90 degree. And this is where you have to be very careful. In circle theorem questions, you're not just getting the circle theorems. You have other angle rules you can use and you have to use in questions like this. For example, in here you have a triangle and you know the rule angles in a triangle add up to 180, which means to find h, so to find angle ABC, you have to do 180 minus 32 plus 90. You have to do this because all these three angles add up to give you 180 degrees. So let's just do that now and you will get 58 degrees. Once again, you have to give the reasoning for your answer. Angles in a triangle add up to 180 degrees. So let's move along to question number 3. The diagram below shows a cyclic quadrilateral. Points A, B, and C, A, B, C, and D touch the circumference of the circle. Line BD goes through center O. Work out the size of angle marked H. Explain your reasoning carefully. So, so the clue is in this question actually. So they've told you it's a cyclic quadrilateral, and there's only one rule that you can use in terms of cyclic quadrilateral. It is opposite angles in a cyclic quadrilateral add up to 180 degrees. So in here, what angles you have? So you have this and you have this. You could use the others, but it's not a full angle, so I will leave that out. So to find h, you need this angle, but we don't really have the angle, so we need to find this one first. So to find angle BCD, once again, you have to use a rule that's not circle theorem, which is angles in a triangle added to 180, which means these three angles add up to 180, which means this angle is 180 minus 33 plus 57, which is 90 degrees. So you write down your reason, which is angles in a triangle add up to 180. Now moving on to the next part. So if this is 90 degrees, then X is also going to be 90 degrees because angle BAD is 180 minus 90, which is 90 degrees. And the reasoning for this is opposite angles in a cyclic quadrilateral add up to add up to 180 degrees. Do excuse my horrible handwriting, but you understand the rules. At any point in this video, if you're getting confused by the rules or if you don't know the rules, watch the previous video. It carefully goes through the 8 main rules of circle theorem and you'll be good to go with this video. Yeah, so let's move on to the next question, question number 4. Points A, B, and C are all on circumference of a circle or represents the center. Calculate the angle X, give your reasoning for each step. Once again, this topic or this question is heavily influenced by a known circle theorem rule. You will see as you go along. So to find X, one of the things you could use here is, the line AO is equal to line OC. How do I know that? So OA is equal to OC. The reason I know this is because OB. Oh, let me write it a bit more neatly. So OA is equal to OB is equal to OC. How do I know this? They're all radius. So radius is the line from a center of circle to the circumference. So all three of these are radius, and as you all know, the radius of a circle is always the same, which means this triangle right here is an isosceles triangle. Isosceles triangle has two sides which are equal, which means their base angles are also equal. So this tells you angle OCA is equal to 22 degrees because base angles of isosceles triangles are equal. Yeah. And once you have that, you have the next triangle right here where you have OB and OC. So once again, this is 67, which means this must be 67. And if you have a look, that means angle OCB is equal to 67. And it uses the exact same rule as previously. Base angles of isosceles are equal. Now to find the value of x, you will know 67 minus 22 because by the previous rule you found this is 22. So once you do 67 minus 22, which gives you 45 degrees, you're done with this question. So to be very honest, it didn't really use any kind of circle theorem rules, but it got influenced by the knowledge of circle. For example, you needed to spot that all three of those lines was radiuses and therefore they are equal in length. So it's very important to keep your mind open but still concentrated on the topic. Yeah. So let's move on to question number 5. Point A, B, C are all circumference of the circle or represents the center. D and DC are tangents to the circle. Angle CDO is 22. Calculate the angle H. So just underlining the keywords. Always try to underline the keywords just to make sure that words are standing out to you in a test or generally when you're doing problems. So always give reasoning for each step. So they want the X. So straight away, I kind of noted the shape of angle inside. Angle in the center is twice the angle at the circumference. So this is the angle at the circumference. Therefore, I need to first find this angle because these two are directly related. Now, how can I find these two angles? To find this, first of all, I have to find one of them. If I want to find one angle or this, I need the other two angles. I have already have one, which is 22. Perfect. And now this is one of the circle theorem rules. So you have a radius OC, which is meeting a tangent CD, which means the angle between them is 90 degrees. So when a radius and a tangent meet, it creates 90 degree. So angle OCD is equal to angle OAD because they have the same rule. So both of them is equal to 90 degrees. Once again, you write your reasoning when radius and tangent meet, it's 90 degree. Yep. So now you have 22, you have 90, which means you can easily find the angle in the center. So the angle in the center, so angle COD is 180 minus 90 plus 22. And that should give you 68 degrees. So just write down angles in triangle at 280 degrees. So as you can see, my explanations are getting shorter and shorter as I get more lazy in working out because mathematicians generally don't like writing sentences, but try to keep your writing as um, descriptive but concise as possible. Try to include the keywords like adding together angles in triangle, 180. So make sure you keep your keywords in there, even if you're being a bit lazy. But try to be as descriptive but a bit concise because you don't want to take chances in your real test. Yeah. So you realize this is 68 degrees. So now I can pretty much say the exact same thing. So this would also be 68 if this is 68. The reason being another circle theorem. So when two tangents from a point meet a circle, they are equal in length, which means we have a triangle with same angle, same side, and then same angles inside. So what that means is it's a similar congruent triangles, which means both of them have the same angle. Now, if you were to half that, you will get 68. Therefore, x is 68. And your reasoning would be angle in center is twice the angle at the circumference. So if you have any questions about my explanation, leave it in the comments below so I can answer your questions. So that's pretty much it for this question. Moving on to next question. So it looks a bit complex. It shows you it's double seven, so kind of expect that much work. But regardless of how any questions look, always have a read. Underline the keywords, always have a read. So points A, B, C, and D are all on the circumference of the circle. So you're pretty used to this line now. Point X is the intersection between line AC and line DB. Angle CHB is 110, angle XAB is 22, angle BCX is 23. All of these are shown in the diagram below. Calculate the angle XBC. So what are they referring to? So XBC. So they're referring to this angle. By now you should all be experts in this. You should be able to straight away see a triangle there. So this is the triangle, and should know angles in a triangle add up to 180. Therefore, angle HBC is equal to 180 minus 110 plus 23. So 180 minus 3, which is 47 degrees. Notice how I did not provide any reasoning for this. This is because they simply asked me to calculate. So keywords in maths are very, very important. If they asked you to calculate but didn't ask for reasoning, leave out the reasoning. Just calculate an answer. Yeah. So let's move on to next question. Calculate the angle DAX. So we have DAX. So you might be a bit misleading into thinking this is the angle they're referring to, but no, they're referring to this angle. So always make sure um, to guide you towards the right answer. So you need to calculate the angle DAH. So straight away, I know this is 110. How do I know that? It's because vertically opposite angles are equal. So this might not even be useful to me, but always when you notice something, write it down. You don't want to forget it in an exam, so if you notice, write it down. So let's have a look here. So what other rules do we have? So since we look, one of the way in which we could do this question is very simple. So we'll be focusing on one of the circle theorem rules, which is angles in the same segment are equal. So if you look very closely, you can see um, that these angles are both from the same segment. Therefore, if this is 47, this is also 47. So very straightforward. So angle DAH is equal to 47 degrees. In here, you definitely have to give a reason. Your reason is angles in same segment are equal. So pretty straightforward, but a bit harder to spot with other angles there to mislead you. But always have a deep look, remember the 8 circle theorem rules, and you would be just fine. So moving along to the next question. So I think it's the second to last question we have here. So what do we have? Points A, B, and C are all circumference of the circle. O represents the center. Angle DOB is 2x plus 28. Angle DCB is 3x minus 70. Calculate the value x. So what you have here is you have a combination of algebra involved with circle theorems. So whenever algebra is involved in any kind of topic, that's level 8 to 9 topic. They elevated the difficulty of the topic to make it harder. But do not be alarmed. The theorems are still the same, so all you have to do is have a bit more algebra knowledge to solve this. So let's have a look into see what theorems could be applied here. So there are many theorems you could do here. One of them, but it's not very straightforward. So if you have a look here, right? This is angle at the center. Which is twice the angle at the circumference. In here, you don't really need to give a reasoning. You have to simply calculate. So I'm simply going to do my calculation. Angle DAB is 2x plus 28 divided by 2, which is x plus 14. How does this help me? So now if you look very, very closely enough, you will notice this is a cyclic quadrilateral because all 4 points of this quadrilateral touches the circumference of the circle, which means um, this angle plus this angle add up to give me 180. So 3x plus minus 70 plus x plus 14 should give me 180. Now it's purely algebra. You simply collect the items, solve for x. like them. So that's 4x. And in here, you have minus 70 plus 14, which will give you minus 56 is equal to 180. And then you add 56 on both sides. You will get 180 plus 56, which is 236. So 4x is equal to 236. You divide by 4 on both sides. X is equal to 59 degrees. Nice clean number. Perfect. So hopefully that question was straightforward. So once you understand the where the values are coming from, it's quite straightforward. Now moving on to the final question we have. So points A, B, and C on the circumference of a circle with center O. Points C, D, and E lie in a tangent line. AB is equal to AC. Calculate angle CDO. To be very honest, the diagram looks quite complex, but don't be alarmed. Once again, have a calm look and see where you can go from here. So we are trying to find the angle CDO. So this angle. So to do this, quite a lot of things you could do. First of all, you can just write down the information you notice. So this is 46 because they are isosceles. Once again, they told you AB is equal to AC, so these two are also same length, which means they are also isosceles. These two angles are equal. So now what you can do is the angles in the triangle add up to 180, which means this angle right here is 180 minus 46. It's 46, which is 88 degrees. So this is 88 degrees. Once you notice that, angle in the center is twice the angle at the circumference. So this is 44 degrees. So that is 44. And once you notice that, you will realize this angle plus this angle plus this should add up to 180 since they are triangle and isosceles triangle specifically, which means it is 180 minus 44, which is 136. 136 divided by 2, which is 68 degrees. So this whole thing is 68, which means just a small extra bit is 68 minus 46, which is 22 degrees. So this is 22 degrees each. Now you have many ways to figure this out. So one of the ways you could do is 90 degree, because um, when a radius and a tangent meet, it creates 90 degrees, which means the small extra bit here is 90 minus 22, which is 68 degrees. So this is actually the extra bit here is 68 degrees. Now, what do we have here? So you have 107 here, which is 107 here. Whatever this angle is, that's the same as this. So both of these is x. So x plus 107 plus 107 is equal to 360 degrees. Why is that? Because angles around a point add up to 360. So that is 2x plus 214, which is equal to 360. Now you solve for x. You don't really need to create this equation, but if it helps you, go for it. I'm just doing it because I prefer to always just create an equation. So you divide by 2 and you're left with 73 degrees. So this is 73 degrees. Now, on the final stage, we are moving along to the also familiar angles in a triangle add up to 180 degrees. So the 73 plus the 68 plus this, the value we need, gives us 180. So this 73, 68 is equal to 180 degrees. So that is 39 degree as a final answer. Notice how I did not provide any reasoning because it was simple calculation. It did not require any reasoning at all. But you can slowly understand why it is a level 9, the hardest you can get, because it was not straightforward at all. It was quite complex. It will take a lot of time to notice this in a real test. But try to just write down everything you notice as soon as possible. Underline the keywords, start from what you want at the end, then just try to write down every rule you notice in the sense of the angles so it can guide you towards the right answer. So thank you for joining this um, watching this video. Hopefully you found it helpful. Let me know how you found it in the comment section. If you want more videos like this, let me know as well. Have a good day. Bye.